Okay. So is there anything for homework before I get into this here? Alright, I'm never sure how to take that. We have no questions. No questions. Alright, fine. Okay, so last time we started barely looking at this. Yeah, thanks, Chris. Okay, where am I? There. Alright. Work with me. Don't watch. Alright. Seasick. Oh my god.
I'm so good.
Help me. Alright. Hey, look at that. There you go. Alright, so. I don't think we got as far as figuring out what method to use on each of these, right? Did we say that? Oh, it says shell. So I can remember for a second. My whole purpose of this handout was to do the same region two different ways, just to show you it was possible. Sometimes it won't be possible one way, which is kind of nice, because then you're like, well, it's got to work the other way. So if I'm doing this first one with shells, let me just draw in the rest of this region real quick, since my computer didn't want to do the whole thing. Where do these meet here? 1. Because it's pretty easy to see these meet at 0, 0, and 1, 1. Kick ass. So this is the region I'm going to rotate around the x-axis. I'm going to rotate it this way. Alright, for me, that is just freaking hang that on the wall for me. For normal people, that's just don't let people see it, but for me, it's damn good. So I'm going to rotate this around and make this weird bowl shape. So, shell, so I know it's going to be integral d what? I love it, because it's around the x-axis, standing parallel to the x-axis. Shells will be the opposite of discs. That's one reason they exist. And it's all about, really keep making the same points with you guys. It's all about, if I have a function I can't solve in terms of y, then I don't want to use a method that requires dy, for example. So it helps you determine which method to try. Here, I could solve very easily for x or y. So technically, either method might work. So what's nice about the way that I've been given these functions, they already are in terms of y, which is nice. Cool. So what do I have to determine for shells? What do I have to figure out for shells? What do I draw?
Your height or your cylinders?
My height. I got to draw. I don't have to draw any cylinders, thank God. It was hard enough for me to draw what I just did. Right? So how are my rectangles going to be oriented? Are they going to be standing up or laying down? Laying down, because they're all about, I want to make them and then rotate them around like that. More like that, but I can't do that with my arms. So I'm going to have, like for example, here's a representative rectangle. So let's see, how long is that? Where does that start? What's the top of it? What's the top of it?
The function minus the other function.
Do it.
Function minus the other function.
I like it. The function minus the other function. What's the top? Try again.
Y.
Yeah, I mean, so again, why would you say, now just stay with me. Why would you say that this, where's the top of this? Where's the top?
4.
Because that's where y is bigger. Right? So if I have one opening this way, where's the top? Where x is bigger. That's all. So where's the top here? Over here. And what's that defined by? X equals y. I'm going to stop there for a second. So section 6.1 was all about finding areas between curves. So what I do, if I was trying to do this area, I could do it on the y-axis, and I could say integral from the line down to the curve. I mean, I could subtract those two functions. It would be the integral of the subtraction of those two functions. That's section 6.1. Cool? So shells very often could feel like that. And the reason shells is so cool, if I try to do this with discs, we're going to have to do that for part 2. What am I going to have to identify for discs? Inner and outer radius. So, I mean, shells don't do that. They just only draw the part that actually deals with what's going to end up being there. Discs do the whole thing, and then I got to subtract the other disc out. That, to me, is kind of unsatisfactory. I want to just include from the beginning the only part that's going to matter. So my little rectangle, poor little rectangle, it goes from the line down to the curve. So the height of this rectangle will be what?
Y minus y squared.
Y minus y squared. I like it. So what else do I need for? In fact, what form am I using for shells? What's the formula behind it?
2 pi
2 pi r
delta
h, and then the thickness, which is dx or dy, right? Let me stop there for a second. So you got pi r squared, which is almost too easy to believe. The disk method is really nice in that respect, but you got to square your radii, which leads to disgusting polynomial foiling very often. Does that make sense? Right, you guys, we've seen that happen. Shells, nicer in my opinion, but you can't always use them. That sucks. And the 2 pi r is your circumference times the height. That gives you that, when you unfold that Campbell soup can label, that's the area of that rectangle. That's all it is. So I'm trying to give you ways to remember the form of these things in case I decide I'm not going to let you use that for the test. Yeah, I'm still thinking about it, but don't try to influence me because that's only going to backfire. Alright, let me stop there for a second. So as soon as you identify the method, and here I'm being really nice, I'm telling you what method to use because I wanted us to use both anyway, who cares? As soon as I identify the method, you got to write down the form of what you need and then figure out what it is you need. So we need the height, we got the height. We need the radius. Well, how do I find this? According to the y-axis, I love it. So the radius, and I'm rotating around the x-axis, so just straight up y. So where's that rectangle sitting? How do I find that rectangle? How would I draw another rectangle? I draw it like this. So I find my rectangles along the y-axis. I go, here's a rectangle, bam. Here's a rectangle, bam. That's why I find them. That's part of the reason, in this case, them, like this. That's part of the reason why shells are the opposite, the dy, dx. It's opposite from what you're going around. It's perpendicular to that. You locate them perpendicular to where they're rotating around. To be honest, that always made more sense to me. I just like Shell's method better. It just makes more sense. I'm rotating around the damn thing, so I should find them this way, in this case. That's how I find and rotate around. Discs are a little weirder than like slicing a ham. Like I find it in the same way. It just, personally, it just makes a little more sense to this. And you're like, dude, that's nice for you. Alright. So what do we got here? We got, what do we figure? R is Y. So do we have everything you need? Yes, we got 2 pi. I can put out front because it's just a constant. Inside I've got R, H, dy. So what was R? Y. H.
Y minus y squared.
Cool. And now all I have to do is figure out what my limits are. Yeah, my y. And for this problem, you can't go wrong because both x and y are going from 0 to 1. But yes, because my y is going from 0 to 1, every single y from 0 to 1, I can find a representative rectangle that goes along with it. Wow. So it's 0 to 1. Okay. My God. Go ahead and try to do that integration. This should be the easy step now.
I think the answer should be y over 6.
We'll find out. We'll catch up to you, John. Yeah, so it comes out to the I agree. Now, you have to understand, if you had any trouble going from here to here, that is a huge red flag. Right? At this point, at this moment in this course, that should be remarkably easy. If it's not that way, you got to come see me or do something. You got to get it there. I like it. So is everybody decent with that first type? Shells, okay. So now we know what the answer is supposed to be. I don't care what method I use, I better come up with the same damn answer. It's a piece of ham. I don't care if I cut it this way or cut it that way or what. Right? So let's see how far you can get. Try to set up number 2. And of course, it's different. It'll be integral d what?
Yes.
Yes. This one shouldn't be too evil. This one kind of works out really nice because we have a radical. We had to solve our equations for the x. One of them was very easy. This one's also very easy. But when I square, of course, it's going to make that really nice. So how do I set this up? What's my outer radius?
Square root
Square root of x. And what's my inner radius?
x.
X. So this would be integral, of course, from 0 to 1. Can't go wrong with it. Because x goes from 0 to 1. Pi, r outer squared is square root of x squared minus r inner squared. So I get x minus x squared. Cool. And then we get pi. What do you get when you integrate this?
Minus x squared.
I like it. So we got, most of the time I think I default to doing x squared over 2, x cubed over 3, but it doesn't matter how you write it. From 0 to 1. Again, the 0 doesn't do anything, so when I plug a 1 in, I get 1/2 minus 1/3, which is 1/6 pi Thank God, because we already knew that was supposed to be the answer. So there's nothing magic that these came out to be the same. In fact, they better freaking come out to be the same because they're both defining the same bowl, right? And just to really hammer this point home, you got to be able to not just know the little details of how to set up a problem and then how to integrate it and so and plug the numbers in the right order, all that kind of little detail nuts and bolts. But you get the whole big picture behind why do we need an inner radius and an outer radius. So if I just had the parabola, right, and I rotate this bad boy around, I'm going to get this solid mound, this solid thing, right? Chunk down. I don't know what the hell this thing is. Right? Looks like the what were they called coming out of the swamp? The Legion of Doom. But if I take this one,
You killed it.
totally, and I take this, rotate this piece and just take it out, just cut that piece out. That's what we're doing. So it's the pi r O squared, that leads to a solid dome. And then I cut out the part that's defined by this, I just subtract it out. I mean, it's just a 3D version of this old thing. What's the area of the solid of the shaded region? We did the trapezoid minus the circle. Ooh, it's the same damn thing. Alright, I know I've said that before, but really just to make sense of the problem. This is why there is no washer's method. There's this method, that's it. Sometimes you got to use 2 and subtract because you don't want the inner piece. It's not washer method, it's not a whole different method. Same damn method. I like it. Cool. Okay. We finished that. Okay. So any questions on those two? I'm going to show you one example that works decently nicely either way. Which method was better here?
Probably shall.
Speaking purely objectively, I'd say discs for this one. But we see now discs can go bad really quickly. The minute either one of these functions has more than 2 terms, that kind of gets to be sucky to multiply that thing out. Right? Okay.
I was gonna ask, but you kind of answered it already. Like, why isn't it r outer minus r inner squared? Like parentheses.
Oh, well, yeah, because we are doing a complete problem. So what we're really doing is we're figuring out. This would be like the dome, right? That would be like the dome. Yeah. And then I subtract out the cone. So that's why I square the radii separately, because I'm not finding a new radius. If you subtracted the radii and squared, you're now doing a smaller disk, which doesn't cover the whole shape, doesn't make any sense. So that's why it's not this. This is what Troy's asking. Good question, why is it not this? Because I don't want to find a new radius. I want to find this shape minus this shape to end up with just the part they want me to rotate. Kick ass. That's the kind of question I live for. That's the kind of question. And then Troy, that's right. That's a good question. Why the hell is it not this? And this gets to the point of what the process is. What's the process trying to do? It tells you why the math does what it does. And then it's not a memorization thing. It just freaking makes sense. I know I say that a lot nowadays. Don't memorize. Just make it make sense. And then you don't memorize. You just do the damn thing that makes sense. And, it sounds easy when you say it, Jeff. Yeah. You good? Okay. All right. I don't know. I was kind of expecting more questions, so I didn't come with terribly much. We can do a problem or two out of the homework if you have a suggestion.
Can we do 18?
Which one?
86.3.
Number 80? No. 18. Oh, yeah, okay. I love it. That's a good problem. All right. So those of you who have not done this one yet, you can thank John for helping you out here. 6.218. Chris, can you turn the lights back on? Thanks. All right. There you are. So take a minute and see if you can sketch this region they're talking about in number 18. Just see if you can sketch that region. And shade it in. The practice does. Yeah. All right, we catch up to, what is this better known as? X-axis. I love it. Y is 0 at the x-axis. So let's see what we got. We got y equals x. Okay, that's easy. Here's 4, 2. Shua! Make that big. X-axis, x equals 2. What kind of line is that? Vertical. So I'm talking about this. Let me erase that part so I don't confuse myself. So that's contained in those lines. It's contained between those boundaries. So what really sucks is if you do all the work, but you're using the wrong region. You didn't draw the region correctly. That sucks so bad. But thank God you got a teacher who gives you partial credit. If you do everything right after that, you'll get most of the points. But this is the region they want you to do, and they want you to rotate it around x equals 1. Ooh, it's even better. So I'm going to rotate around that. Kick ass. And this is in section 6.2, so this is before we knew shells. So we're going to use discs. So try to draw in, what do I need for discs? And in fact, more specifically, how many discs am I going to need here? And do you see why? Do you understand what I was trying to say earlier? When can I tell that I'm going to need more than one disc? When my axis is not touching somewhere my region. That means there's a part that I need to subtract out. So if I only did this radius from here to here, I would get all this shit in here I don't want. I want to subtract that part out. Okay, cool. I like it. So can you guys notice an immediate issue that's going to happen when you're trying to identify our inner and our outer? What's our outer going to be? How far from the rotation axis to the outer edge? Yeah, good. So this is 1 to 4, so that's 3. Good. When you try to identify our inner, what happens? Yes, it's 1 somewhere, but it's not always 1. Do you see that? Why was this a single thing? Because does this ever change? No. But what happens? Is it forever like this? Oh shit, it takes a turn. So what's our inner here? So this is our outer. What's our inner here? 1. Cool. So that's constant because those are parallel to each other. So the distance between them will be constant. That's beautiful. So that works for what to what? And what am I doing this? Let's take a step back. Integral d what?
X. Or Y.
I like it because this disc method, I'm rotating parallel to the y-axis, so it's going to be dy. So this is for y from 0 to 2. All right, let me stop there for a second. So beyond just the process for discs and shells, you have to identify when something changes in your region. Right? So until 2, it's really just a rectangle here. That's easy. And then here, things drastically change, which means I want to set up 2 separate intervals. Because I'm going to have an interval from 0 to 2, when everything is the same. And then things change, and then I'm going to have an interval from 2 to 4. Yes, sir.
So it can be more than that if it's not.
Totally, yeah. If they really wanted to be jackass to you, you could say like, this is a parabola here now, and all this weird shit. Yeah. I'm not going to do that to you. Out of the most one place where things go freaky, right?
When you say things change, you mean when the function changes?
When the definition of one of your functional boundaries changes. Exactly. I like it.
So I mean, your boundary can be squiggly and be changing, but it's still the same function, and you don't need to do 2 disks.
Exactly. So the definition of the boundary has to change. So this boundary here is defined by x equal to 2. This boundary is not. That boundary is defined by x equal to y. I like it. So good point. It's not just because it doesn't go straight, it's because its definition has changed. Okay, maybe. And we'll see sometimes, we've already seen situations where I have a parabola and then I have another parabola, and I'm talking about the area between them. This is a horrible picture, but too bad for everybody. Right? Talking about that area. So if I was going from here to here, it's the top and the bottom are defined the same throughout. Do you guys see that? The top is the purple and the bottom is the black. Yay! But if I had to do going this way, and I'm doing like shells or something, here it's from there to there, here it's from there to there. It changed. So I'd have to split my integral up, whatever that is. Does that make sense? So if either way would work, I might try to use the way that requires less integrals to be set up. That's just one more thing to determine which method you want to use. Possibly. Okay. So what's R inner here?
1 minus the function.
1
Careful. What's bigger, the function or 1?
Y minus 1.
What's bigger?
1.
The function's bigger. And I need everything in terms of y. So what is this function? This is x equals y. So inner radius is y minus 1. Bigger minus smaller. Bless you. Always. Do you guys get what I'm saying? If your function is on that side of the axis, it's going to be function minus axis. If it's the other way around, it's going to be the other way around. It's just bigger minus smaller. That's so awesome. Wouldn't that be good?
So if your region is in the negative side, you would do the axis.
Minus and negative, yes. So then it would become out positive. I like it. Cool. So it doesn't even change then. Don't try to overthink it. Just whatever the hell it is. You're going to do the big minus the small, and the small is negative, it becomes plus because 2 negatives make a positive. It's not because you had to know ahead of time that was going to happen. All right. Okay, all right. So I got my, so I need 2 integrals. One integral is going to be from 0 to 2. The other one's going to be from 2 to 4. And I'm using what method? Disk. So what am I going to put out front? Pi. Good, because it's pi r squared. So what do I have in there? Oh yeah, no, too many parentheses here. So I got r outer, which is 3 squared. Minus, for 0 to 2, yeah, from 0 to 2, r inner is just 1. That kicks ass. That's nice. Because from here to here, this is just one big ass circle minus a tiny circle. Ooh. Because the radii stay the same length for both the whole way. Then all of a sudden this big ass circle minus constantly changing size circles. Ah, shit. And that's why the inside of this one's got to be dependent on y, because the radius is going to change. As I go up from here to here, my radii gets bigger and bigger and bigger as I move up. So inside here, it better depend on y. Here, it don't depend on shit. Because the one is 3 and the other one's 1. Always. From 0 to 2. I like it. Maybe. So then r outer, of course, is still 3. R inner now.
Y minus 1.
Kick ass. And for disks, I don't know if you guys notice this. For disks, it doesn't even matter really if you get that 1 minus y if you did the radii the wrong way, because you're squaring the damn thing anyway, to be honest. But just to keep you on the right track for shells, Shells, it totally matters which way you do it.
So you make it like a 9 and then integrate with the 3 squared?
Yeah, it is. What's inside?
9 minus 1.
So what's inside? 8. And what's the integral of 8?
8x.
dy.
D1 equals
So it'll be pi times 8y from
2, 0.
0 to 2. Okay, that was easy. When the inside's constant, hell yeah. That's some nice shit. Now over there, what's inside? I got a foil and stuff. Right? You simplify the inside. One of the minor themes, or major minor themes of the semester, simplify what the hell it is before you try to attack it. Don't try to integrate this directly. Yeah, actually, this, let me see if you guys, well, I wouldn't want to do this. Side note. Don't even write this down. Side note. What is the integral of y minus 1 squared? Don't foil.
Y minus 1 to the 3rd.
Or 3.
Yeah.